Another detail that we need to make this blockchain idea work is to not actually use a linked list. Problem with the linked list is to do anything with it, you have to start at the very beginning and run all the way through it. So if you wanted to verify a particular transaction, you have to look at the entire history of the blockchain to validate that one transaction. Real blockchain systems instead use something like a Merkle tree. So tree data structures instead of lists is going to make it easier to validate an individual transaction in the blockchain. It's still conceptually a chain, but organized as a tree, which is, as we'll see, is a kind of shortcut to get to certain transactions without destroying the blockchain nature. Another thing they do is instead of making every block an individual transaction, so that every little transaction requires this proof of work and so on, multiple transactions can be grouped into a single extension. So this creates a market for middlemen who gather up transactions and then do the work that is needed to generate the proof of work to make those transactions acceptable. And then these middlemen need to be rewarded in some way, and the reward comes in two ways: mining rewards and transaction fees. Let's look at the Merkle tree part first. A Merkle tree is a tree that represents a linked list. The way you get to the nodes of the linked list that it represents is just an in-order traversal. So here the transactions are at the leaves, T1, T2, T3, and so on. And instead of T2 computing its hash code referring directly to T1, we just compute these node hash codes directly, but then we form a node in the tree by taking the two hash codes of its children and hashing those, and working our way up here. So at the root of the tree, there's a hash for the left and a hash for the right. And by taking that two combinations, we get to hash 0. That means hash 0 here covers everything in the tree. So it does the same thing that a linked list hash would do. But the advantage of doing this tree structure is if I want to confirm this transaction 4 here, I can get its hash, and then the tree says that that hash is combined with hash 3 to get this other hash b, and so on. As long as I trust the spine of the tree here, then I can trust that T4 really is a transaction in this blockchain. That's only validating one transaction, and it's assuming that the rest of the tree is okay. Another good feature of this tree, though, is if I want to validate the whole tree, then I don't have to work just one node at a time. I can do the left subtree at the same time as the right subtree, say. In other words, I can apply parallelism to validate this whole tree.